Polyurethane foam is the most modern insulating material. It is used mainly for sealing and filling the gaps between window and door frames and the wall. The application of the foam is simple, quick, and it does not require any special tools. The thermal insulating properties of polyurethane foam are considerably better than those of traditional materials. The thermal insulation provided by the foam is 8 times better than wood, 60 times better than concrete, and 80 times better than mortar. Polyurethane foam has quickly become the most popular material for sealing windows and doors in Western countries, where great importance is put on heat retention and energy saving. For the last 30 years, foam production technology has developed significantly. Due to improved formulas and new technologies, modern polyurethane foam provides excellent insulation and makes the installation of windows and doors easier and more cost-efficient. The research and development works conducted by the Salina Group have also exerted considerable influence on the development of the world foam market. Salina laboratories have produced, among other things, the first in the world mass-produced high-yield gun foam, Titan 65, the first in the world mass-produced high-yield straw foam, Titan Lexi, the first in the world foam for PVC windows with very high adhesion, multi-position foams that enable application in different positions of the can, numerous products with unique properties, including winter PU foams, fire-retardant PU foams, foams for special applications, as well as foams that are safer for the user's health. Today, Titan Professional PU foams are highly appreciated among professional users and are sold in more than 50 countries worldwide. Modern foams have unique parameters in terms of yield, immediate growth, expansion control, economy of use. These advantages have been obtained due to advanced technological and chemical solutions that were developed in Europe only at the beginning of the 21st century. Yield. The yield is the volume of cured foam obtained from one can. The X foam is based on the traditional chemical formula. The standard can size is 750 milliliters and the gross weight is 906 grams. The yield is often mistaken for the gross weight of the can or for the foam growth in a gap. However, the foam amount after curing depends only on the chemical formula. Titan foam is based on a modern formula. Its standard can size is also 750 milliliters and the gross weight is 903 grams. After applying the two types of foam simultaneously into a testing container, we obtain twice as much Titan foam as X foam. Immediate growth and controlled expansion. Immediate growth means that after application, the foam expands up to 70 and sometimes even up to 90% of its maximum volume. Due to this property, it fills the whole gap completely, thus ensuring a perfect seal and high adhesion. Controlled expansion, on the other hand, means that the foam growth within the gap is constrained, while the high yield of one can is still maintained. Therefore, such foams do not exert pressure on the window and door frames, and thus prevent bowing. Traditional foams lack the properties of immediate growth and controlled expansion. Economy of use. High-yield foams and foams with controlled expansion are very economical in use. The high yield means that we can obtain more foam from one can, which in turn means that we pay less for 1 meter of sealed gap. Controlled expansion lowers the costs by maximizing the foam use. How the foam is made. The production of PU foam is fully automated. The foam is a chemical product. It consists of two elementary chemical substances in liquid form, prepolymer and gas compressed into a liquid state under high pressure. After it is released from the can, the pre-polymer reacts immediately with water from the air. It is only then that the polyurethane foam is made. That is why the quality of the foam after application depends considerably on the external factors, for example, air humidity and temperature. The water content in the air is of key importance to the quality and quantity of the foam after application. The higher the humidity, the greater the foam growth, and the better the quality of the foam. Therefore, it is recommended to spray the application surface and the foam with water. The quality of the cured foam is also affected by the can temperature, ambient temperature, and atmospheric pressure. In cases where the can temperature and ambient temperature are too high or too low, the product quality and yield can be significantly lower. The foam consists of reactive chemicals. From the moment the can is filled in the production line, the chemical reaction is initiated. This reaction continues until the foam is released from the can. That is why the contents of the can undergo gradual changes. Therefore, fresh foam has better parameters and better yield after application than older foam. Transport and storage conditions. Polyurethane foam is an aerosol, that is, a product under pressure. It is flammable and it poses a risk of explosion when exposed to high temperatures. As a chemical, the foam changes its properties when it is stored at too low or too high temperatures. In order to maintain high quality of foam and ensure the safety of use, the elementary transport and storage conditions must be met. Cans must be protected against fire, sunshine, and temperatures exceeding 50 degrees Celsius, as well as against humidity and frost. Foam cans can only be transported and stored in vertical position, at temperatures ranging between 10 and 30 degrees Celsius. Inappropriate transport and storage conditions may cause foam aging and reduction of shelf life, blocking of the valve, reduction of yield, gas leakage preventing foam application, foam shrinkage after application, poor adhesion and foam runoff, holes in the foam structure after cure, foam cracking and crumbling. Window installation. Correct application is indispensable to obtain good quality foam. For proper functioning of windows and doors, it is necessary to leave a gap from 15 to 20 mm wide between the frame and the wall. Take down the window from the jamb. Protect the jamb with masking tape if the window is not covered with the protection film. Support the jamb on blocks and lift it up to vertical position. Check the position of the frame in the rough opening. See to it that the installation gap, the vertical and perpendicular position of the frame, and its diagonal are correct. Ensure the proper positions by means of spacer blocks. Install the anchors into the wall by means of plugs, or in the case of older methods, drill holes in the jamb and in the wall from inside in order to screw the anchors and install them by screwing into the ready-made holes to the leveled window. Install the windows and regulate them if needed. Dust and moisten the joint between the wall and the window. Prepare polyurethane foam. Fix the foam to the foam application gun, shake it and regulate the gun. Application of water increases foam efficiency and lowers the costs by as much as 30%. The temperature of the polyurethane foam can is very important. Follow the manufacturer's instructions concerning the temperature. The optimum can temperature for the commonly used summer foams should be in between 18 and 25 degrees Celsius, while the ambient temperature from 10 degrees up to 25 degrees Celsius. Fill the gap between the wall and the frame with the polyurethane foam to 70 to 90% of its depth, leading the can evenly from bottom to top so as to fill 100% of the volume. While the foam is being applied, keep the can vertically upside down. The foam should be released at a constant speed. If the foam is released too rapidly, the gas will escape and the efficiency will be reduced. When the foam has solidified and cured, remove the wedges and spacer blocks and fill possible gaps with polyurethane foam. Recommended time, after 24 hours. When the foam has completely cured, remove the surplus of it and start the mortar works of the jam. Recommended time, after 24 hours. Experienced installation workers who use controlled expansion foams are able to minimize the material loss by as much as 20%. Carry out the finishing works. After the mortar finishing works have been completed, remove the protection film from the window. Selena, technology of trust.